I would like to welcome everybody to today's roundtable event, Delivering Reliable and Functional Communications to First Responders, sponsored by Context Satellite Network Technologies. Before I start introducing the panelists, I would like to mention a few housekeeping details. There is a question and chat function that I would encourage you to use, so please ask questions throughout the session. We will try and answer all the questions, time permitting. If we don't manage to answer all the questions, we will follow up after the event. And should we lose a speaker, we will continue and restore their connection as soon as possible. And should we, in the unlikely event, lose me, the moderator, I am pleased to say Richard Swald will take over. Now let me start by introducing the panelists. Our first panelist is John Hefner, Senior Vice President, Orbital Data Networks. Being named Senior Vice President in November 2018, John was Director of VSAT Services and was responsible for all the company's VSAT offerings. He was also closely involved with pre-sales engineering efforts, as well as other business development responsibilities. John began in the satellite industry in 2008 as a field systems engineer, primarily servicing public safety and land mobile radio customers. John's time in the field has helped him develop a unique perspective on the challenges these specialized mission-critical network operators must overcome. Next, we have Mark Littlejohn. Mark is Context Satellite Network Technologies Vice President, Strategic Accounts. In this role, he manages and maintains relationships with key multinational organizations to assure business continuity and consistent customer satisfaction. He has worked at Context for 16 years in various roles, including North America as Vice President, Sales and Government Programs, wherein numerous critical captures were accomplished. And finally, Richard Swald is Senior Vice President, Premium Enterprise and Mobile Operators for Context Satellite Network Technologies. In this role, he leads the market development and direction for the telecom and enterprise markets, directing long-term strategic initiatives and defining solution suites and feature sets. Welcome, gentlemen. So let me set the scene. When disaster strikes, one of the first critical tasks is to get communications up and running. It is widely recognized the importance of the first 72 hours of disaster response. So with that in mind, what are the main challenges facing first responders at the site of a major disaster? John.
Thanks, Richard. I think ultimately first responders probably have an infinite list of challenges they have to overcome. But if we want to just focus in on connectivity as a primary challenge they deal with, there's in the modern world, there's so many different ways for first responders to manage their connectivity needs, right? Your standard first responder is going to use some kind of land mobile radio network, and then on top of it, some kind of contended internet connection, typically for asset management and just general communications. Over the last few years, we've seen a lot of contended cellular networks and other high-performing contended networks come to market and get heavily adopted by these operators. And I think a big challenge of that is the difference between something working and not working, completely on and off. And in a contended network, there's this whole big gray area, right, of how well something's operating. And if they haven't put in an engineering solution that can solve that problem, they're going to end up in a situation where they have varying levels of quality of service throughout the event, right? They may show up on site, get their internet up, whatever they're using, cellular, FirstNet, satellite, whatever it is, some contended service, right? And it may work, and then they have this operational challenge of managing that connectivity as it changes throughout the day or the week as other operators come online, other agencies come and start using the same connection path. So they're balancing that risk, right, of a contended network versus the cost risk of, having this expensive dedicated service they would purchase, right? So there's a balancing act there that I think first responders have to deal with, and I think it's a major challenge for them.
Richard, have you got anything to add to that?
Well, as John was saying, every situation and every disaster is unique in a way, and the challenges are different. But one way of approaching it is like just in a medical emergency, you need to do a triage of sorts. You assess the situation, you make priorities, and resources will always come up short and be contended in the beginning, and quickly you need to get them to where they make the most and best impact. So communication is, of course, a critical tool to help assess and manage a disaster. And here, satellite has always played a key role. It is highly portable, easy to move around to where it needs to be. It's power efficient, so a car battery or a portable generator or even solar panel is all that is needed, and a clear view of the sky. And satellite communication can then provide the most basic functions you need to get started with telephony, internet access, and backhaul to land mobile radio sites, for instance.
Now, have we really learned the lessons from numerous major disasters that we've encountered over the last 10 years? Mark, sorry, would you like to start off with that one?
Of course. Thank you, Richard. Yeah, of course, progress has been made. There are networks at local, state, and federal levels that are designed to be interoperable. A lot of attention has been given to that. And then stepping beyond that is making those networks interoperable and looking at standards throughout the industry. But at the end of the day, we as a society have so many options when it comes to communication. Everybody's going to whip out their cell phone. The first responders are using the networks we're talking about here. So there's a lot of progress to be made. A lot of people have wish lists that really, at the end of the day, there's the law of physics when it comes to radio frequencies and access and signal availability and interoperability. So will there ever be one entirely ubiquitous system that everybody uses? Probably not. But yeah, progress has been made, but we have still a long way to go.
John, do you think progress has been made?
Yeah, for sure. That was a great point, Mark. I think the interoperability point is really important. You know, back when we started in this industry in the early 2000s, we didn't see a lot of agencies working together. Everyone kind of did their own thing, right? So even within like the same state or municipality, different departments didn't really work together, right? They kind of did their own thing. They had their own strategy for how to respond to an event. And because of that, there was a lot of problems during a natural disaster or any kind of incident to actually communicate with each other. And it was only after, I think, Katrina really that we saw a lot of interoperability between agencies start to take place, especially on the LMR side. And then, yeah, I think the other point Mark made that was great was regarding, you know, the limited available space in the microwave spectrum and how that's a physics issue. I think, you know, blending, there's a lot of stuff going on with 5G and blending different types of connectivity together. I think that's going to play an important role moving forward as a lesson that has been learned is, you know, you can have your satellite connectivity that's foundational, highly resilient connectivity. You can bring in other connectivity options as well and blend them together. And then you're in the best situation to be able to rely on that and put a mission plan together as a first responder where you can actually rely on that connectivity, right? Because there's no single point of failure at that point.
Okay, Richard, do you want to add anything to that?
Yeah, some good points made there, both Mark and John, blending it all together into one solution. Today actually marks 30 years ago since Hurricane Andrew made landfall in Florida. And at the time, that was the most damaging hurricane that has ever hit the U.S. And part of the reason why the effects were so devastating was that just a few days before it made landfall, it wasn't even categorized as a particular severe hurricane, and evacuation orders weren't given in a timely manner. Since then, forecast models has improved, and so has building codes and such to better withstand the effects of wind and rain. However, there's always lots to be learned, and in a way, I think we never finish learning. It's also so that the effects of natural disasters are changing, and some research suggests that weather-related incidents are getting more frequent and more violent, and more people are living in the affected areas. So disaster recovery plans and building codes or even floodplain maps that were reasonably accurate or adequate just a few decades ago are simply not sufficient today. And we just experienced something in Kentucky to that effect. People that didn't even live close to a 100-year floodplain were affected, and buildings and roads and bridges were just swept away. And this disaster, just like Andrew or Katrina, severely limited the ability to use phone lines and cell towers and the internet, because the communication equipment was either underwater or without power. And here satellite communication again comes in as a lifeline with its unique capabilities, and we hope federal and state and local agency pay attention. Satellite is a really key solution to.
Richard, I would just I would add to Richard's point. I live on the Gulf Coast. I've lived through a lot of these storms, and even the best laid plans, unfortunately, sadly, something's learned through every disaster. There were downtown buildings, medical district in Houston that had plans on top of plans. No one ever thought that there'd be such a flood that their gen sets would be underwater in the basements. It's just that scenario had never played itself out. So unfortunately, we'll continue to learn after every event.
Yeah. So I know we've touched on it, but what is the biggest key consideration when implementing this critical network as a first responder? I mean, John, probably directed at you as your.
Yeah, I mean, it's a complicated subject, right? And I think the first consideration is kind of look at the particular agency and what their mission is, right? So treating first response as just this blanket topic that everybody's trying to do the same thing is a really good way to kind of shoehorn a solution into a situation where it's not really designed, right? So like a hospital or an EMS organization is going to have a completely different mission than the police or like Department of Public Safety, right? What they're going to be trying to accomplish during a natural disaster or some other kind of deployable event are different, and different technologies are tailored for different missions. So I think as network operators and solution providers, it's important for us to actually understand what the customer mission is and not try to just design products that fit as many possible missions as they can, right? So custom tailored solutions, I think, is an important consideration, making sure that we're fitting the mission that needs to be carried out. And then the second one is, it's a reality we have to understand, and that we're going to talk about it more later. I think funding is a huge factor. First response is, for connectivity, a lot of times it's equipment that sits in a barn, right? And it may not be used 5, 6, 7, 8 years. And as you have different, at least at the government level, you have different decision makers coming in and out. They look at the cost of that equipment that's just sitting there not being used, and it's easy head to chop. And so a lot of times it gets turned off, or it doesn't get tested, or for budgetary reasons, they stop putting manpower behind testing it, and then all of a sudden it's been a decade and they need it and it doesn't work anymore, right? And we say that all the time. So I think those are two kind of not obvious answers to the question, but I think they're ones that should be brought to light for sure.
We've got a question coming through on Skype, which is unusual in itself, but it was one of the things we were going to talk about anyway, which was equipment compatibility. Is that a problem? Now, I suggest Mark leads with this and then Richard jumps in.
Well, that's a multi-headed question, because there's so many components involved, and that is one of the challenges. Fortunately, in today's IP world, most everything's IP based, and the interoperability, the compatibility is there. We're dealing in the CommTech realm. We're dealing in the the network data and transport layers, and most everything there is pretty much standardized. And so our traffic interfaces to the devices, being native IP or routed IP, are pretty standardized. We deal with and address multiple protocols, more than you could list here. New things come out, we adopt, we adapt, we make available to interoperate with that. So here again, I have a bit of a tunnel vision as far as equipment. We're concerned about our demarcation from Ethernet cable to Ethernet cable on either end of a satellite link. But then there's the world outside of that. And that goes back into, as we were discussing earlier, interoperability among perhaps disparate or separately owned networks. But I would say equipment compatibility, as I think you're asking, is not so much of a challenge anymore.
Okay. Richard?
Yeah, and Comtech has a really rich history in this area as well. We've been involved in critical networks and dispersed network for many years, and supported critical application like air traffic control, military communication, and today land mobile radio. And we have a lot of experience and knowledge in this area. Comtech sells solutions that are able to work with legacy protocols like frame relay or TDM or serial communication interface, even UHF, VHF, and manage them and carry them transparently over our solutions. We have ways of compensating for challenges like jitter or difference in delays that can exist between different means of transporting voice and data. So in this case, for the PMR network we're talking about today, we were able to meet the stringent KPIs and the performance requirements that the vendor set out for us to meet when it comes to jitter and latency. And we do that with advanced quality of service capabilities in our technology. So yeah, we can deal with most every challenge that is thrown at us with our solutions. So.
Now, John, you mentioned about funding. So let's talk about funding. It's clearly key to maintaining a critical network. But is the funding freely available to install and maintain these networks, or is it funded differently between government and private entities?
Well, I don't think anything's funded freely available, unfortunately, right? But yes, so they're definitely funded differently, right? Government and private entities have different goals, and you know, for private entities, there's not as much of a public safety or first response effort there, right? So in a lot of cases, the big difference is how they're going to justify the cost, right? So in the case of like government agency or first responder, they're justifying the cost by solving a mission requirement, right? They need this connectivity to meet some mission requirement for their first response efforts, right? And then they find something that's cost effective to do that, and then they purchase it with tax dollars or grant money or whatever the funding source may be, right? Ongoing funding, like I said before, is a challenge, though, right? They can get it purchased and they can get it funded for so many years, and then they have to refund it, right? Either through another grant or through tax dollars, or typically it's a new fight every year to keep those systems funded, right? In the enterprise and private sector, it's a little more black and white, right? It's how does this save us money? How does this make us more efficient or you know, more competitive? Whatever it may be, there's usually a business case that has to be made, and then the funding can become available based on that, right? So if you show a private company you can save them money or make them more efficient or more competitive, they're probably going to purchase it, right? So I think it's just they're two different challenges, and they have vastly different goals, right?
Okay, let's concentrate a little bit on ODN at the moment, because you're heavily involved in these type of networks. So you're said to be the first and only VSAT provider to deliver specialized and proprietary VSAT technologies, specifically tailored for land mobile radio tower backhaul. Why is that so important?
So if yeah, for sure. So if you see like a first responder, like the first thing they do when they get out of their truck or vehicle or whatever it is they pull out a land mobile radio, right? That's usually the first piece of communication technology that's used, and it's relied heavily upon. You know, most 911 dispatch systems, most EMS, fire, police departments in the country, they operate on LMR systems. They're not, you know, they use cell phones for some things, but generally their day-to-day communication between each other and dispatches via state and federal LMR networks, right? And we saw a huge hole here after Katrina. So when Katrina ran through, it tore the state of Louisiana's LMR network down. I mean, it just tore it apart. So there's not a lot of, you know, focus on this industry, but LMR networks are typically hub and spoke based. So one of the primary requirements is for dispatch centers to be able to dispatch fire, EMS, and police, right? So those dispatch centers typically do not sit at the scene of disaster. They're going to be the inland, in-state, wherever they are, right? And so to get out to those tower sites, there's usually some kind of backhaul technology in place, right? During Katrina, it was usually T1-based serial backhauls. And those backhauls got destroyed, right? By that hurricane. And so dispatch couldn't dispatch, again, fire, EMS, and police out to fence. They just couldn't do it. There was no way to communicate. Even if they had like a command center that they rolled up and they have internet connectivity, they still really don't have a reliable mission plan on how to communicate with dispatch over the internet, right? They all relied on their LMR networks. The LMR network was down, or what they call site trunking, which is you can only communicate within that tower site, right? It has no backhaul anymore. And that was a huge problem during Katrina. It caused all kinds of operational hazards. So we saw a problem, and we went and we found a solution, right? So we've determined that geosatellite and cellular networks and these other technologies were great backhaul options for to protect these vulnerable tower sites from losing wide area trunking. And we've been deploying that ever since the last 17 years now, all over the nation.
Now we have a question that's come in from CRISPR. So how are these networks going to perform when you've got some of these huge wildfires where the sky is consumed by smoke and flames?
So no communication solution you can honestly say will work under all conditions, right? But when you blend connectivity from different technologies, you get the advantages of both, or whatever, however many number of connection paths you create. So in our case, the foundational connectivity path is VSAT, right? So we come in with this really high resiliency link, and then on top of it, we put other links, right? Whether it's microwave, T1 fiber if it's available, cellular connectivity. And by blending all of these together, you end up with a situation where that tower site becomes extremely resilient to all different kinds of severe weather, right? Or natural disasters. So, obviously if the actual tower site is burned down, there's nothing to connect anymore. But, short of that, yeah, it's very resilient.
Okay.
Yeah, a little bit of smoke will not affect the communication, or even a lot of smoke, or cloud cover. I mean, what can affect communication long distance is water, and that's precipitation, obviously. But there are techniques to mitigate that with something called adaptive coding and modulations that adapts to the link conditions and make it very resilient and robust. And then, as John is saying, you can have backup options to the backup option as well. So it's
just throw this in to the equation, Richard. Do people underestimate how important satellite is?
Oh, absolutely they do. And then they misunderstand what satellite of today can do. I meet with many people outside the industry that clearly misunderstand the capabilities. I hear from a lot of people that it's slow, it's expensive, it's cumbersome, it's not reliable, difficult to manage, and so forth. But that is not true. And I sometimes struggle how to explain it in layman's terms, but of all the great things we have. But I like to drive the parallel maybe with the cell phone industry and how we use cell phone has evolved from 2G to 3G to 4G to 5G with increased speeds and increased capabilities. And so has the satellite industry been on a similar journey for the last 20 years. Speeds are great today, and we have advanced mechanism to secure superior quality of service. And in times of congestion or shortage of bandwidth, we can prioritize traffic based on many different quality of service rules. We can base it on application, VLAN IDs, diff certs. We can get very technical, but at the end of the day, we can ensure that we fulfill key performance indicators and SLAs with today's satellite technology, just as well as terrestrial networks can.
Slightly in a tangent, John, LMR is not just available for disaster recovery. As a day-to-day commercial use. Can you tell us a little bit more?
Yeah, so these LMR networks, they're deployed for geographical coverage, right? Not necessarily population coverage. So the side effect of that is you end up with tower sites in extremely remote and rural areas, whether that be the side of a mountain or next to a river in the Midwest. These are areas where connectivity options are extremely limited. So VSAT fits a great role there, right? It can be cost competitive, it can be performance competitive. If you're talking about using something like a T1 or a legacy circuit, the primary commercial application is in these areas. The terrestrial connectivity is extraordinarily expensive. Either there's a build out cost associated with it, or it's just not available at all. And this would be where the commercial application comes in for this VSAT-based LMR solution. It's either option one, it's the only choice. So you're either going to have a site-in-site trunking, and that's how for years, we had to position VSAT as and this kind of goes into what Richard was saying, there's this preconceived notion that it's low performing. So a lot of times the only way we could market it in the past was as the only option, right? If everything else is dead, that VSAT makes a great solution. And we're seeing that change finally in the LMR market because these commercial operators are seeing that this is a cost-effective solution. And so now they're looking at the performance again and they're saying, oh, well, actually it performs better than we all thought because we haven't touched it in 10 years.
That solution that you offer is a flexible network architecture. What does that mean? Why is it so important in the context of what we're talking about?
Yeah, so this is a CommTech technology that we rely heavily upon. So UHP platform is extremely flexible in the different VSAT topologies that it'll support. We rely heavily on the star and mesh topologies for those that are familiar with VSAT architecture. And they've allowed us to basically create multiple redundant paths with a single telecommunication asset. So without getting too in the weeds, when we use the star architecture, there's a reliance on some terrestrial backhaul components to make LMR networks work. And for natural disasters, operators don't want to have that terrestrial link involved. They want to have it completely off the ground. So we use point-to-point VSAT in those events, right? And they don't have to purchase two assets to accomplish this. For day-to-day operations, they could use star, which is cost-effective. It has a terrestrial component, but again, it's a lower cost option. And then if there's a natural to disrupt that terrestrial component, the VSAT asset will switch to a mesh topology. And we rely heavily on that capability for especially in the government sector as a cost savings. We can basically offer two backhauls for the price of one.
Mark and Richard, the ODN solution, it provides unmatched performance. What products is CommTech supplying to enable the solution?
Richard, I'll jump in. John made mention of it, the UHP platform, which is UHP is actually an acronym for Universal Hardware Platform. The concept behind that is a software-defined board set. To John's point, and he's stolen my lines here. It makes it very, very versatile. We were software-defined before that really became a cool term. The ability to adjust topologies. We mentioned both the point-to-multi-point, star topology, and mesh. It gives the user a lot of flexibility. We also see, and it's becoming even more critical, not just the system availability purposes, but from security purposes, geo-redundant hubs, user-owned hubs, eliminating public switch or public internet networks for security reasons, keeping bad actors off the network. So that is the core solution, and of course there's a lot of features involved with that to aid in ease of use, ease of implementation, configuration, troubleshooting, everything else.
Richard, do you want to add to that?
Yeah, I think Mark covered it really well. I mean, it is a significant network, fully geo-redundant over two satellites, and I believe we're now around 500 sites or so, John, right? So it's a significant network as well.
So we've probably touched on this, but what is the key component of the UHP equipment advantage? What is the key? Why is it better than the competitors out there?
This is our chance to do a shameless pitch.
Go for it, Mark.
Let's face it. No. And we've touched on it a little bit. There are obviously a litany of features. I mentioned the software-defined nature of the platform, and the flexibility and the cost-effectiveness, versatility. Second's performance. I mean, just at the end of the day, Richard alluded to this earlier as far as the economics. In this world, using a satellite operator's assets, it's all about cramming as much as you can into that wave, that radio wave. So the term that's used is bits per hertz. So we're unmatched in this type of solution in the bits per hertz value, which equates to dollars spent and dollars required. And then capacity is as far as overall capacity. How much can we ingest and transmit? And for this particular application, the platform has more than an adequate amount of capacity, and is the case about any application anymore. You'll run out of satellite bandwidth before we can run out of processing capacity. And then for this and any voice, especially voice application, it always comes down, and like John said, stay away from the techie stuff a little bit, but it's jitter and latency. Voice applications, be it LMR, cellular, terrestrial type backup comms, are very jitter and latency sensitive. And then finally, if I had to make I guess it'd be a third point, would just be the simplicity. So without ours is a purpose-built network management system designed for this. It's not a derivative or a customization of something else. So I mentioned some of these earlier: configuration, site provisioning, adding sites, troubleshooting, getting key performance indicators, acknowledgement of performance is all simplified through our system.
Okay, before Richard, did you want to add anything?
Yeah, well, I would also like to add, like Marcus already pointed out, the flexible and modular nature of the platform, of course, is really helpful. We can tailor it to its mission application it's trying to serve. But in this particular case, also, we're able to have a single remote that is supporting both the start configuration for the day-to-day operation and that critical mesh connectivity as a disaster recovery solution when any terrestrial facility would fail, so we can connect directly from a LMR tower into a switch site directly using the same hardware. That's really a unique value proposition, that we get two different topologies in the same platform.
Now,
Well, I'll give you one more as from the host network operator perspective. It's the agility of the platform, right? We talked about earlier how these, not LMR specifically, but these public safety agencies and these first responders have specific missions. And with other VSAT platforms, it was hard for us to do a lot of custom tailoring for those customers' missions. We kind of had to make a product and just sell the product. It was too hard to micromanage the platform per customer, right? And the way UHP does per site, per user, per network customizations, it makes it easy for our NOC and our support and our management teams to actually support really custom solutions. So we're able to go out and market really specific custom design network solutions with that VSAT platform and actually manage and support them properly, which was difficult on other platforms for us just because of their rigidity. So they may do one single thing better, but they can't do anything else, right? So that level of flexibility has been amazing for us as an HNO.
Now, before we move on, we've got some questions coming in. There's one from Adrian Times. It's about VSAT. How fast could VSAT come online if there were some areas where LMR suddenly did not work due to an unanticipated disaster? and needed a satellite solution to become operational very quickly. Now, I think that's a very difficult one to answer, Richard or Mark, but somebody take a shot at it.
Well, I can. I mean, we have systems specifically in place for what might be referred to as a business continuity, meaning that the absence of the primary comms is detected, and the systems in place. I mean, obviously, if you're having to roll out a VSAT, an antenna set, that's one thing. There's different scenarios here. If the system's in place, it can come on in the time it takes to get signal acquisition and transmit and be received into the network. That can be a matter of just minutes. We work with a lot of mobile network operators, other first responder systems people have seen in their communities, an emergency response vehicle with a clamshell antenna on the roof. Those are designed to roll out to a disaster. We work with mobile network operators that have groups dedicated to emergency response, where they'll bring, so we're getting off the LMR subject, I apologize, but they'll bring mobile cell backhaul to an area, whether it's because of loss of towers or overuse, an emergency and the system's oversubscribed. They'll bring in mobile units, and those can be up within hours. So it's a matter of preparation, preparedness, but to another point, and that's just one of the inherent advantages of satellite. If you can see the sky, you can connect. So I'll let Rich add on to that.
Yeah, I mean, that's the key point, right, Mark? It's available anywhere, anytime, and provides a consistent and cohesive service under the footprint of the satellite. It looks and feels and behaves the same anywhere under the footprint, and that means that as a customer, if you have an event, you can go to a service provider like ODN, and you can get coverage basically anywhere in the world, and the solution will support the same SLA, the same KPIs to each and every site. It's easy to integrate and easy to replicate. In terms of procurement, operations, it also helps us. There's one relationship to manage. You don't need to go to service provider X for T1 there, or service provider Y for a fiber connectivity there. You have one company to work with, yeah, it's a good. Okay. Satellite is very, very quick and easy to deploy and flexible.
We're going to take another question here. It's from Lawrence. What are Comtech and ODN's relationships like with international aid NGOs who are operating on tight budgets, doing what government aid can't do in disaster areas? What are the relationships like? John, do you want to take that one first?
I think Mark probably has a little more experience in this area.
Yeah, we can. I mean, obviously, it's regional in nature. There are humanitarian organizations throughout the world that rely on satellite. Obviously, they're going into areas that have little to no infrastructure. We're working with a company right now and providing educational services in areas where they planted the scenario and said, there's no power in these villages. So we're having to look at photovoltaic, we're having to look at gensets, but yet they want to bring education. It could be the same for any sort of disaster. You know, it's a different nature, but it's not too different from the military, where we do a lot with both domestic and foreign militaries, and they're going into places where there is no comms. So, you know, you're looking at power efficiency, you're looking at mobility, you're looking at ease of operation. It's just going to vary from NGO to NGO, country to country. We've worked with various UN entities around the world. We've got a long history with that. So there's similarities, but then every application is going to have its own unique requirements.
And they see the benefit of satellite, obviously, because it's available everywhere, and it's a consistent and cohesive service. It looks and feels the same wherever they go. So the services and applications that they rely on to deliver their services locally, they can deliver that over satellite by bringing their own connectivity to wherever they go, and it just works. They don't need to rely on a local entity, a local MNO, and a local service provider for the connectivities. For them, they see a lot of value of bringing their own solution.
Okay. Coming back to the main topic, John, ODM works with a number of different technology partners. What attracted you to Comtech, and have there been any challenges in implementing what you've been doing?
I think we've talked a lot about accidentally what attracted us to the platform. You know, it's the stuff we've already discussed, the ability of the platform, some of the key capabilities of the UHP software-defined architecture that have worked for our customers, and therefore we've moved forward with that technology for quite a while now. There really haven't been a lot of challenges. I mean, early on, anytime you bring on a new OEM partner, and for the OEM, you're working with a new network operator, there's always challenges. You know, working with each other, making sure that the technology fits the application for that customer, and just generally kind of the normal growing pains, but it's been a great relationship. It's given us some key competitive advantages that we didn't have before, and hopefully we've taught Comtech some stuff about this market as well on the other side. So
now, we've touched on this about why satellite is crucial. I think it'd be nice to go into a bit more depth on this. Why is it so critical to, crucial to critical networks? And how do we get it out to a broader audience, how useful satellite is? Richard or Mark to take that one? I think Richard to start.
It is a continued educational effort, like the seminar we have today. We need to explain the advantages that satellite brings, the differentiators, the availability, resilience, and the robustness, and like Mark was saying earlier, if you can see the sky, you can get connectivity, and that's basically one of the key selling points, right? Many terrestrial facilities, they rely on cables, cross connects, switch rooms, and those all rely on power, and the weakest link is if there's one step in that chain of communication without power, the entire network breaks down. Whereas satellite, we go to space and we come down somewhere else, and only those two endpoints needs to be have power and not be underwater or subject for any natural disaster. So it is this robustness, resiliency, and speed that is the key components and the values that we can bring to this industry. So we will continue to push for satellite and talk to state, federal, and local agency to encourage them to look at this technology as another tool in their toolbox to ensure that they have the preparedness they need when disaster strikes, or also for the everyday work of all the emergency services and public safety agency, where they go out and tend to the constituents and the people living in the areas. So that's what we continue to do.
Mark, do you want to add to that?
Yeah, I'm impressed with my colleague here, Richard. He avoided the term ubiquity, because that's almost overused in our industry. But it is. I mean, you look at and here again, there are companies like John's that specialize in this. So satellite's intimidating to a lot of people. I don't understand anything about it. I don't know what parts and pieces are required. I don't know anything about satellite link budgets or contours or EIRPs and all these, this alphabet soup. But at the end of the day, when you understand that the satellite's footprint, and there's a number of satellites available that cover the entire continental U.S. or pick your region, you're dealing with one satellite, and that first site, yeah, there's a little bit of engineering and design work. Companies like ODN will take care of for you, but after that, every site is easily stood up. So you've done the work in the front end, and unlike a lot of technologies, be it microwave or trying to run fiber or do anything else, going back to that see the sky, you take that same kit, point to the satellite, and you're on the network. There is no work after that. So as long as you're under that footprint, which is in our region here locally, coast to coast, border to border, and beyond, the repetition, the duplication is simplified. You have a standardized kit, you go to your site, you point to the satellite and get receive, sync, and you're on the network. It's really not a lot more complicated than that. So that's a real strength for the companies looking at deploying this. Get beyond that first site, and the deployment's pretty easy after that.
Well, one of the questions coming in is, how do we ensure these network speeds throughout the crisis situation? Now, I know we've touched on this, but let's go back to basics. How do we ensure that there's that speed there and there's no problems during a panic situation?
That's the magic question, right? So we were talking about contended networks earlier, right? So one of the advantages to VSAT networks is you can have your own. It doesn't have to be contended, or you can just contend with your own sites, right? When you're in a cellular network or even just a regular terrestrial internet network, it's a contended network, and you're not sure who you're sharing with, right? And some providers have brought in quality of service and priority, but you're still only prioritized the same way as other priority people are, right? There's only so much capacity on a cell tower. If it's all used, you're done, right? Geo satellites can share capacity from massive geographical areas the size of continents, right? So you have capacity that's being contended across huge geographical areas that can be moved anywhere, right? It's available anywhere within that massive footprint. And that's a huge advantage in a natural disaster, because if you have a hurricane in Louisiana, the guys that are using that same satellite in Alaska probably aren't using it very much right then, right? And so that capacity can be reused in a lot of cases. If it is contended, and in other cases with certain customers, it's not contended at all, right? It's a private network. You have your own satellite network, your own space segment, and you've designed it to be contended among your own sites, however you want it to be, right? Whether it's a 50 megabit circuit that your capacity that you're sharing with only 10 sites or 50 sites or whatever you decide. That's the beauty of it, right? Is you have this control over your operation and your network capacity. That you don't get. And VSAT's also sold as a managed service, right? In the same way cell connectivity is. You can buy it just from a shared service provider with a maximum up speed and a maximum down speed, and it's a contended service. But you have that second option, right, of standing up your own network with your own capacity, which is pretty unique to geo satellite.
Okay. There's a question come in from a Don Richardson. It's directed both at Richard and Mark, really. Several companies are developing integrated cellular satellite end-user devices. Is this a development path for Comtech?
Integrated satellite cellular technologies.
End-user.
End-user devices, integrated cellular satellite end-user devices. Is this a development path for Comtech?
Okay, well, I can speak a little bit to that if I understand the question correctly. So what is happening in the industry right now, in the mobile industry, is that there is standardization ongoing that is merging satellite communication with wireless communication. So in the standardization bodies that handles 2G, 3G, 4G, and 5G, it's called 3GPP, they have currently released the first version of the standard that will allow for a cellular handset to communicate both with the terrestrial base station as well as a satellite. And that can happen seamlessly. So there are companies now in the industry, and we are working with several that are looking at building a satellite constellation that is essentially a cellular base station from space. So your handset will have the capability to be connected to a terrestrial network when it's within reach, and when it's outside of reach or when the terrestrial network is down, it will automatically connect to the base station that is flying in space instead. So I think that was the question, and yes, that is happening. It's still a couple of years out before we see that in any larger scale, but it's a very, very interesting development that is happening.
Okay, brilliant. John, we've predominantly been talking about these networks which are in use in the US. What plans do ODN and partners have to expand this solution globally?
Yes. So we are working with international partners. So we work with some of our key strategic partners are the largest LMR OEMs, and then we also work with some international satellite operators. And we're looking at putting hub systems for LMR solution in Europe and Africa are the first two regions that we're looking at. So there are plans to deploy it internationally. We're just it's a slow process, and COVID definitely slowed it down even more. So
why did you choose those? You said Europe and Africa. Why were those two regions chosen?
Europe, because it's the easiest region, and as far as LMR networks are concerned, they're designed very similarly in Europe as they are in North America and the US. The major OEMs that deploy networks here have a lot of very similarly sized and designed networks in Europe. So it just made a lot of sense operationally to go there as the first rollout. The regulatory burden there for getting landing rights and for doing satellite connectivity in Europe is not as bad as it is in some other regions. So it just made a lot of sense as the first region. And then in Africa's a good choice just simply because it's got pretty poor infrastructure in a lot of places. And VSAT compares very favorably if there's no infrastructure, right? Because you just don't have that requirement of having terrestrial power, terrestrial connectivity, and then they still rely on LMR networks there in a lot of cases. So it made sense for that reason. So those are the two primary markets and the reasons we're going there.
We've got a question here which I've left until near the end, but how do you work with customers to test out the network in the field? Sounds basic, but how do you know the technology will work under all conditions? What is the process you go through to test it?
Well,
So go ahead.
I'll take the first stab at that. There's obviously we have experience on our side, so we're operating in over 170 countries around the world. Every satellite constellation that's ever been launched, with systems doing from transmission rates in the kilobits up into gigabits these days. So yes, I said gigabit, and I'm talking satellite. We have multi-gigabit links in various parts of the world. So that breadth and depth, but to a specific user, we obviously can do demo systems, proof of concept efforts. There's a number of ways to let them get a feel, a test drive, if you will. It depends on the application, depends on the location, depends on the user-specific requirements. But yeah, no one goes into this blind. And that's my job, and the rest of the team's job is to make sure the comfort level is there, and you get what we advertise.
Richard, do you want to add anything to that? Or
I mean, we've been in business doing backhaul and connectivity for more than 30 years. We have a relationship with all major OEMs, vendors. We met and came across multiple technologies in many different industries, and have the capability to to test and verify and work with our customers to ensure that SLAs and KPIs are met. So that's something that we bring to the table, and John as well, with his experience in the LMR industry for this particular project, was of course super critical and brought a lot of experience to the table as well that helped us design the right types of solutions needed.
Yeah, and one of the answers we give to our customers or potential customers when they want to test it is, by nature, VSAT doesn't care about the conditions at the location. That's the nature of the technology, right? When you're testing out other technologies that are terrestrial based, you have to worry about things like that. But as long as the antenna will physically still look at the sky and the satellite's still there, it's going to behave the same regardless of if the ground is flooded or there's a bunch of fire damage or whatever the conditions are. It just doesn't care. And it makes it easier to test it in a controlled environment, just because those variables are somewhat irrelevant, frankly.
Okay. Well, we have another question, which is relevant after I've asked you my question, and that is, what network challenges do we face moving forward? And are there still improvements that can be made?
I mean,
Who would like to take a stab at that to start with?
we're in a constant mode of continuous improvement. I mean, we want to continue to deliver customer traffic at a lower cost, higher speed, better performance, but also in a more secure manner. We see an ever increasing threat from bad actors that wants to inflict harm into networks. What was it? Last year, Colonial Pipeline had an incident that is quite famous here in the U.S., where there was bad actors that came in and shut down the distribution of fuel from to the East Coast for several weeks, a cyber attack. But what are the great advantages with satellite and what we can offer and ODN is offering is that it's a private network. It's a secure network. Doesn't have to be connected to a public switch or a public internet, and that reduces the threat surface and limits the points of access for bad actors that wants to get access to the network. Keeping it private makes it inherently secure, right? And besides that, we want to continue to develop further enhancements in our software to be secure, robust, encrypt traffic, and ensure that the critical traffic like land mobile radio and disaster recovery communication is always protected. That's one of the key challenges and improvements I think we can work on going forward.
Yeah, Richard stole one of my initial thoughts was around security. We've invested a lot of resources in securing the network, user authentication, user access, verification. I would add from an industry perspective, and not to take away from the LMR topic here, but interoperability. Do you think back pre-GSM, where you had to worry about which network were you on, or you're roaming and things like that? The satellite industry can get to the point, especially for maritime and other applications moving around the globe, where they don't care about which constellation they're on. So, there's work in that area. I think that's something we'll see going forward. We're not there yet, but I think it will eventually get there, where the satellite user just moves around as need be and connects however and whenever with no concern about which constellation he's on.
John, do you want to add anything to that?
Yeah, I think Richard stole my thunder on this one for sure. Network security is huge. Yeah, especially in the LMR network world. I mean, these are very sensitive, critical public safety networks with a lot of sensitive data being moved across them. So there's, like I said, dispatch calls. There's all kinds of really sensitive information moving across these networks, and because of the massive geographical coverage they have to meet, they're using a lot of blended connectivity, right? There's cellular, there's T1, there's fiber, there's internet connected sites, and that becomes hard to secure just because you've got so many different connection paths, so many angles of attack for bad actors. And the satellite network provides, I'm going to use that word, ubiquitous, right? It's the same everywhere. So it's the same security risk profile at every site. It's a privatized network, and they can keep their traffic completely segregated from other customers and other use cases that are less critical. And that's been a big advantage and a challenge that we continue to work through as we see more and more of those cyber attacks.
Well, that before I asked you that question, one of the questions that came in was about cyber security, and the question is, are they really secure? I think we've touched on this and we've answered it, but how secure is secure? If somebody wants to get in, they will. I mean, do we have a view on that?
Well, zero trust is of course the best approach to any cyber threat. But at the end of the day, there will always be bad actors, and you need to find ways of reducing the what's called in the industry the threat surface. And one of the best way of doing that is exactly what John is doing, and that is providing a private network that is dedicated for a single use or a single customer, where they are in control of everything end to end, even the physical access to the system. I think that's hard to beat. That's not to say that it cannot be attacked. It will be attacked. Anything will be attacked. That's just the nature of the world we're living today. But it's one way of taking a significant step forward when it comes to security. It's making it private.
And finally, because we're very close to the time here, finally, what do we feel is going to be the next big game changer for the industry? I mean, John, you're dealing with a lot of different equipment suppliers. Richard, you are. What do we think is going to be the next game changer moving forward?
That's, that is, if there ever was a magic question, that's the question everyone's trying to answer, right? Because everyone wants to be in on that new latest and greatest thing first. I think Richard discussed it earlier, just that the satellite industry is all of a sudden moving at a rapid pace. There's huge technology improvements being made every day now. And I think keeping up with that is important. And I think throughput's going to be a big factor, right? Can the satellite operators continue to launch satellite payloads, and can the OEMs keep up with the throughput requirements of the modern age? And so far they're doing a great job. So I think, monitoring that situation and making sure that the satellite industry is up to the challenge is important. I think it is. And there are some key technologies that are coming out in the satellite industry that I think that are going to allow that in the next few years. Richard?
Yeah, and I think, and this will spark innovation, right? So prior to the smartphone and prior to the cellular industry enabling a higher speed of data at the lower cost, communication over cellular network was text-based and it was voice-based. I think nowadays the least things we do on our phone is voice or text. We're using our phones for a million other things. And I think we will find that our industry will evolve in similar ways, that we cannot only imagine what they will be going forward as the cost of our connectivity goes down and the cost and the speeds and the throughputs increases going forward. So it's an exciting time to be in our industry. In fact, there's never been so much money invested into space technologies as in the history of space as currently is happening. And there's a reason why. There's a lot of optimism in the industry of what this industry can do and enable going forward.
Mark, do you want to add to that?
I think I touched on it a little bit, would be, satellite and constellation interoperability. Obviously, there's a number of things. It's one thing I enjoy about being in this industry. It's never stopped evolving. Just when you think we've reached the apex, there's something new that comes out. So this idea of the handheld to the satellite, there's at least 3 private companies in the process of launching satellites today. I can't wait to see that in action. The challenges, and there are challenges and there are options within frequency bands. There's more bands being available. We're getting into new higher bandwidth frequencies rather. So it just continues to evolve. And like I said, when I entered this industry many years ago, never in my life did I think I would hear anybody use the term gigabit when speaking to a satellite. And here we are today. So it's fun, and it will just continue to evolve.
Brilliant. Well, we have reached the end of today's roundtable. I'd like to thank our audience for joining this event from around the world, and hope you've enjoyed the discussion. I'd like to thank our panelists, John, Mark and Richard, for delivering a real insight into critical networks for first responders. I know we've veered off a couple of times with some of the questions, but it's best to intersperse that, but I hope you've enjoyed it. In addition, I'd like to thank our sponsor, Comtech Satellite Network Technologies. If you missed any parts of the event, the video will be available in the next few days. So thank you very much again, and thank you for joining us.